Now we're going to look at the opposite angles of a cyclic quadrilateral. In the cyclic quadrilateral, you actually know this by a different name. Instead of calling it cyclic, let's go back and refer to it what we would call it. And we would call it an inscribed quadrilateral. So go ahead and cross off the word cyclic and write inscribed. We will call it both. Let's take a look at what's true about the opposite angles of that inscribed quadrilateral. Let's start with tracing the arc PAY. Here's PAY. Let's mark that at 150 degrees. If we look at the two endpoints of the arc, P and Y, they need to be on the sides for my inscribed angle. So my inscribed angle is R. The measure of this has to be half the intercepted arc. So I know that, well, we don't want to go there yet though. Let's first of all, before we look at that angle, let's look at the other side of this circle. Arc PAY is 150, but look at this side right here. This side, if I take 360 and I subtract 150, that leaves me with 210 degrees. So I know arc PRY has to be 210 because those two have to add to 360. Now let's go back and look at the angle measures. So if I look at angle PRY, it has to be half of the 150. If I look at angle PAY, it has to be half of the 210. So reason that out for a minute. These two opposite angles in that cyclic quadrilateral, or the inscribed, add to 180. They have to add to 180 because if you look at the arc PRY and the arc PAY, they make up the entire circle, or 360 degrees. So the two angles that are associated with them have to add up to half of that. So let's go back up to the conjecture, and we can type in that the opposite angles of the inscribed or cyclic quadrilateral have to be supplementary. In other words, they have to add to 180, or half the measure of the entire circle. Use that fact when you are given APR at 162. Use that fact to find this angle without finding this arc. You're not allowed to find the measure of that arc first. Good luck.